spring with a constant of 55 Newton meters has a 450 gram mass suspended from it. The spring is attached to a ceiling as shown in the diagram. Now, keep in mind, we need to kind of think about what Fnet, or what Fnet is. So the equilibrium position is the point where net force acting on the mass is 0. In other words, the point where the upward restoring force of the spring is equal to the downward mass of the downward pull of gravity. So say I'm holding a spring up. Say it's attached, and ooh, the slinky's long, and I have a mass on the bottom, and I just let it kind of do its bouncy thing, and then it's stopped. Then it's just stopped. Okay, so it's extended a certain amount of length that's pulling the spring back up, as well as pulling gravity back down. So this mass right now is suspended. So then we assume that Fnet is 0 because it's suspended there. So that's an assumption we need to make to even do this question. So here where it says mass suspended, Fnet is equal to 0. So the first thing here, it says draw a free body diagram of the stationary mass. So here I have my Fg going down, and my Fs goes up. The force of the spring pulling it up. Now, the net difference between those, I'm going to assume is 0 because it's not moving anymore. Do you see that? It's not moving, it's just suspended. Because normally Fnet would be, if this Fs, if this is positive and this is negative, we say Fnet is like Fs minus Fg. Let's write that out actually. So Fnet is equal to Fs minus Fg, or it's plus negative Fg. Either one is fine. It's the same thing. Since neither are moving right now, our Fnet is set to 0. So for this question, Fg is equal to F. I'm going to use a handwritten S just because I feel like the S, sometimes when I do it quickly, looks like a G. I don't know why, but... okay, so now this says determine the extension of the spring. So extension, that is the X value, how far it's extended. So now, similar to last unit, I'm going to kind of derive my own formula from this. So Fg, since I'm on Earth and I'm just dealing with normal things, Fg is m times g, is equal to Fs, which is k times x. Now, that's a note. In your unit exams, sometimes for orbiting things, you would say that Fg is equal to mg, but Fg in orbiting things is g times m1 times m2 over r squared. But anyways, it's just, I don't know why you guys got that mixed up. But. Okay, so what are we looking for? We're looking for x. So mg over k is equal to x. So let's just put that in, 0.450 kilograms multiplied by 9.81 meters per second squared, all divided by 55 Newton meters is equal to x. So x is 0.0802 meters. To sig this, we should write it as 0.080 meters, or that's kind of ugly, so you could write it as 8.0 centimeters, if either one is right, but less digits for centimeter values. Or you could go 8.0 times 10 to the negative 2 meters. That looks nice too. Whatever floats your boat.